Hello there. These next 3 units in Surge 204 are closely related. We're going to build our knowledge steadily, beginning with peripheral vascular and the perioperative considerations it entails. Then, later, we'll apply that knowledge to the concepts of pulmonary and cardiac surgery. Are you ready? Let's go. First, we're going to break down this specialty, peripheral vascular. What does that even mean? By definition, peripheral means away from the center. So if we know that the heart and lungs are at our centralmost location in our body's circulatory system, then we know that peripheral means away from the heart and lungs. You could think of it like public transportation. The bus station is the hub. The bus stops occur along each bus's routes. Think of the bus routes being your blood vessels. Now then, what kind of vessels are we dealing with? In this specialty, we'll be working with arteries, veins, and the capillary network in the entire body, excluding the heart, lungs, and brain. The heart, lungs, and brain require even more specialization. There are 3 major physiological processes that lead patients to needing peripheral vascular surgery. The first is arteriosclerosis. This condition produces thick, hard, non-elastic arterial walls, which is a major problem because we rely on our arteries responding to our body's needs. Our nervous system transmits impulses sent from all over our body and responds accordingly. For example, say you are out walking and you know that you're going walking, but your body doesn't know that you're actually preparing to start running. Since your body has no idea that you're about to begin running, your nervous system is minding its own business and caring about its day. All of a sudden, you start running. It doesn't take but a couple seconds for your legs to send the impulse to your nervous system saying, hey, it's legs down here, and apparently we're running, so we're going to need some oxygen right away. Your nervous system replies, okay, oxygen on the way, and increases your heart rate so that more oxygenated blood can travel through the arteries. But then, say you've got arteriosclerosis. Your legs are demanding more oxygenated blood. Your heart is pumping more oxygenated blood. But your arteries simply can't give. They can't accommodate the increased amount of blood. They don't stretch. They don't give. So then ultimately, less blood and less oxygen are passing through. Long term, this is a big problem because various areas of your body need to be able to demand more oxygen, and arteriosclerosis prevents that, and it only gets worse with time as the arterial walls continue to thicken. The second physiological condition is atherosclerosis. Atherosclerosis is a specific type of arteriosclerosis, but it kicks it up a notch because instead of just the outer walls being affected, the inner walls of the arteries are too. The inner layers are subjected to plaque buildup, which means the outer layers are stiff and thick and the inner layers are clogged up. Now how much blood do you think's getting through to that artery? Not much. Therefore, no bueno. Finally, the third physiological condition worth mentioning is thromboembolic disease, which is when organic or non-organic material is present in an artery and creates a blockage. Examples of this include blood clots, plaque, or even air. Understanding these conditions is really important. Knowledge of the circulatory system allows you to apply these new concepts to the equation and realize that these conditions affect the system, and this system is supposed to keep us alive. Therefore, presence of these conditions can jeopardize one's life. That brings me to the next big issue in peripheral vascular surgery: ischemia. Timing is so critical in this specialty because we have to reduce the risk of ischemia. Depending on the vessel involved, it could be the one that keeps the pinky toe alive, or it could be the one that keeps your intestines alive. That means we have to be focused. We have to be organized. We have to be efficient to maximize movements and minimize downtime in an effort to help our patient. These procedures may take you out of your comfort zone at first. I know they did that to me too. But if you treat every case the same way every time, you will hone those preparatory skills and not think twice about the process of setting up. Whether you've got an hour because you're waiting for a block to go in, or you've got no time at all because the patient's life is in danger. Whew, that was quite an intro, huh? Okay, let's reduce the intensity a little bit and focus on the details. There's quite a lot of medical terminology in this unit, some of which you should definitely already know, but some of it will be new. Since we spoke directly about ischemia on the last slide, you can bet I expect you to know what it means. Additional terms I expect you to know that are not part of your workbook are the terms extracorporeal and hypovolemia. Remember to use your medical dictionary, if necessary, to know these terms. On this slide, you can see the process by which the blood travels through the body. There are several things going on in this picture. First of all, the whole thing belongs to the cardiovascular system. Within the cardiovascular system are the pulmonary system and the systemic system. The systemic system is also known as the peripheral vascular system, but you have to know that. You want to know where each system begins. The pulmonary system begins when the lungs first get involved. Look at your picture and notice how blue arrows indicating deoxygenated blood is entering the right atrium, passing through the right AV valve, and into the right ventricle. That right ventricle is like a starting line for the pulmonary system. As soon as the ventricles contract, the right side is going to pump deoxygenated blood through the pulmonary valve and into one of the lungs. Once the lungs oxygenate the blood, which we'll learn more about in the pulmonary unit, the lungs empty into the pulmonary veins, which are connected to the left atrium. You have to understand that this is happening rhythmically, one heartbeat at a time. The blood travels now through the left atrium, left AV valve, and into the left ventricle. The left ventricle is the starting line for the systemic or peripheral vascular system, because once the blood leaves the left atrium, it enters the aorta, and the aorta is the largest artery in the entire body and is responsible for allowing all of the oxygenated blood in our body to get to where it needs to go. I uploaded an image to the Dig Deeper section of your TED Ed video this week. Make sure you look it over. I think that it's pretty neat. So now that you understand the systems involved, you can learn the order in which it goes. The deoxygenated blood in the right atrium passes through the right side of the heart, then enters the pulmonary system to get oxygenated. Note how the pulmonary artery is the only artery in the whole body to carry deoxygenated blood, and the pulmonary vein is the only vein in the whole body to carry oxygenated blood. The blood travels through the lungs, picks up some oxygen, then heads on over to the left side of the heart. The blood travels through the left side of the heart, one heartbeat at a time, until it leaves the left ventricle and enters the aorta. Now, with every heartbeat, the oxygenated blood is carried to all the tissues of the body to deliver that sweet, sweet oxygen. As the blood travels further and further away from the heart, the arteries will divide and become smaller. Regardless of where the blood has to go, whether it's the kidney or your big toe, it will travel through the arteries until it gets there. And once it gets to its destination, an arteriole branches off of the artery, which then becomes an even smaller capillary. Note, there are arterioles all over all the arteries, serving the tissues all the way from the top of your head to your tippy toes. It is in this capillary network that the oxygen exchange occurs, and the tissues consume the oxygen, leaving the blood deoxygenated. Then, deoxygenated blood is now located in the capillary bed, and it is going to make its way back to the heart through the venules and veins of the body, using the skeletal system to get there. There's a major difference between the arterial and venous systems. Arterial pressure is determined by the heart rate. Venous blood travels back because of the skeletal muscle contractions. The skeletal muscles encourage the venous blood to travel back up to the biggest vein in the whole body, the vena cava. The vena cava is attached to the right atrium, where the process begins all over again. We're going to spend a lot of time studying this, but I expect you to know it like you know your ABCs.